All right, so Bellware questions on the board. It says the given circuit has a current of 0.26 amperes flowing through it, as shown in the picture below. And you see the picture with the light bulb. You have the battery. You have the ammeter that gives you a reading of 0.26 amps. So it says there's that much current flowing through it. It's telling you the voltage that the source is providing the component in the circuit with. And it's asking you to predict what the current in the circuit would be if you add a second light bulb. So I'll give you about 40 seconds to use your clickers to tell me whether you believe that when you add a second light bulb to this exact same circuit, when you add a second light bulb, do you think that A, the current flow will be 0 amps? In other words, there will be no current flowing through when you add the second light bulb. The current will be 0.26 amps, so the same as with one light bulb when you add the second light bulb. C, the current flow will increase, it will actually go up, will be higher than 0.26. And D, the current flow will decrease, it will go down because you added a second light bulb. So give it a little thought, based on what we've done the past couple of days with circuits. And choose an answer. Don't forget to press enter. You should know at this point.
You and your boys any day, 3 on 3.
Yo, seniors?
West side. Oh yeah.
It's a nice guest appearance. Catalog the spirit of our school.
You cannot do that.
20 seconds, go.
Wait, hold up.
No, I'm not going to close it just yet. I just want to see who's answered who hasn't. It looks like we want one person who's hesitating right
I
now.
wonder who that was. I just said, hold up.
5 seconds left.
What do you mean 4? 3. 2. Pick one, Shimmy.
All right, I'm about to stop it. Baba, I didn't even answer, Baba. Okay, good enough. Let's see where we stand. So, we got about 50% of us saying that they think that the current flow will decrease, will go down. That's overwhelming compared to the rest. Some of us believe that the current will not change, it will stay the same, even if you add a second light bulb. And some of us think they will actually increase. There will be more current flow because you added a second light bulb. I need somebody brave to tell me, someone who chose B. Why do you think that it's going to stay the same? Let's go. First of all, let's see who chose. Why would it stay? Why would it go up? Why would the current go up if you had a second light bulb? Why would it go down?
Take it up on A.
So you have to support two things. So you're saying the current will go down because you had a second light bulb? Speak up a little louder, please. What? Kayla, what do you think? It's all right. I'm asking you to give it your best shot. You know more than you actually think. What was your reasoning behind it? Why did you go with what you wanted?
Because I tried to figure out how to turn it on. That's before, so.
What?
And it just makes sense. Yeah.
Why does it make sense?
Because there's two. That's like a big one.
Because like it's taking too much power. I don't know how to explain.
It's like the two batteries are squirting two things instead of just one. So
Well, the battery is the same battery set.
I know, but
It's double numbers.
So you're saying that there's another source that uses the energy. So
Yeah.
what do you think, Ryan? It's increasing. Okay, so Ryan thinks the opposite of that. He's saying that it's increasing because there are two light bulbs. They need more energy. So therefore, you're thinking the energy has to flow faster. Those pools of charge has to flow faster. Is there a reason behind it? Okay. Pat, what do you think?
I put D.
D? D, you think that the current flow will decrease?
Yep.
What's your reasoning behind it?
Pretty much like for one light bulb, just go like a good amount of speed, two, it's just like a little bit slower because that's a little bit. It's like the same amount, but now it's for two things.
What does a light bulb and this guy have in common?
They both take energy.
They take energy.
They both take energy.
That one
Okay.
turns into heat, and that one turns into
That turns into heat, this turns into light. All right, good enough. So they take energy. If you add in the second source that takes energy, right?
Yeah. They're not gonna be as powerful.
So how's it going to affect the flow?
It's gonna be minimal. It makes it work.
Okay,
It's
all right.
like when we tested with a resistor.
Well, I'll tell you what. I'm going to give you a second chance to express yourself.
Oh, really? You're nice.
I am very nice. This time around, you only have about 15 seconds.
What? Wait, so we change our answer?
Don't change your answer. Put the same if you believe it's the same.
Oh, okay.
If somebody in this discussion, if you heard something that convinced you to change your answer, go ahead and change your answer. Otherwise, stick with your same answer. There's a reason you haven't changed.
About 10.
How did Justin Bieber song just suck that?
All right. Whoa. So, let me see that again. 85% thinks that it's Dina.
Now the laugh is wrong.
Well, I don't know. So everybody believes that the current flow will decrease if you add a second light bulb. I mean everybody, but a lot of people, about 85%. Okay, tell you what. You know what? I'm not going to give you the answer. Here's what we're doing. There's 4 circuits around the room.
Oh, then I
2 of them have one light bulb. 2 of them have 2 light bulbs. So what I need you to do is turn those circuits on. So if your group has a circuit, turn the circuit on. You also have the multimeters right next to you. I need you to measure the current flow. The current flowing through that circuit, through each of those circuits. Yes. One second. One light bulb, 2 light bulbs. So we're looking for the current.
Yes, sir.
So you basically, right, you want to make sure that that guy connects it. So that they flow.
I'm look at this. Is supposed to do this?
Now when you measure the current flow, right, you have to make sure that this is the guy that connects the circuit. So you want to flow through there, yeah? 0, you want to try changing the sides. How are you doing here? Okay. All right. Okay. Those who had 1 light bulb, what did you get? 0.27 with 1 light bulb. Who else had 1 light bulb? What did you get, Margie? 0.29. Okay. Those with 2 light bulbs.
0.20.
0.20. Right. 0.20. You got roughly the same.
You're welcome.
Okay. If I ask you the same question again, what would you go with?
G. You're welcome.
Is there any doubt now?
No.
Okay. Now, the easiest way to remember this is that the resistors, all those parts, all those components of a circuit, they use the energy like light bulbs or these resistors that we used in the lab to turn into heat. They take the energy from the coulombs. In a way, they slow them down. Think of the resistors as doors. Those 2-sided doors, the swinging doors. Every time a coulomb goes through, it slows them down a little bit. And he takes that energy from them and he does things. This guy creates heat while the light bulb creates light. You understand? Now if you have more of those swinging doors lined up, which is what happens when you add more resistors into a circuit, the coulombs will slow down even more. Correct? That's what causes the current flow to get smaller when you add more light bulbs, because you're increasing the overall resistance of the circuit. And again, this evidence is too strong to ignore. Clearly, there's way more current flow with one light bulb than there is with two light bulbs, and now we understand why.
Yeah, we're that much smarter.
We learn every day.
I'm not that.
All right, next. Turn your notebooks to the last thing that we used.